So I've had a whole slew of parts arrive over the last week for the 8080 CPU board. I've removed the voltage regulator and heatsink. I just wasn't happy with how that went together, especially looking at the original photos. There's just a huge bag of parts here. There's a lot of redundant parts. I had went ahead and ordered all the resistors on DigiKey just because they're very inexpensive. And some of these I didn't have good match sets in my little drawers. But there's just a sea of resistors here. As always, I bought overstock. They'll just get sorted back into drawers. One set of Zener diodes. Picked up some, these are 220 ohm 2 watt, which is one of the resistors that's required. They're a little larger. But then I had real issues finding the 2 megahertz crystal in this large case style. In my stock I had 1 megahertz and like 2.12 or something, and didn't have anything that was exactly 2. No luck on eBay, no luck like on Unicorn Electronics and other places. And that finally resulted in me, the same gentleman that manufactured the PCB offers a parts kit of all the parts you need to stuff the board. And so after I'd spent all the money at DigiKey, it wasn't a lot of money, all those resistors were pretty cheap, I went ahead and ordered the kit from him. It came with an 8080 CPU and the 8212 clock generator, which I actually already had in stock, but why not? It came with these 8T97. These are bus drivers. I've got a drawer full of these. They're kind of hard to find anymore. So, that's nice to have, especially if I'm replacing them on actual PCBs from the era. The logic that's required. I ordered some 50 volt, 33 microfarad. I believe they are caps. There's 4 of them that go on the PCB. What he supplied is a little bit different. He's got both 25 and 35 volt ones here in the bag. The size on these is very similar, and they're 50 volt. There's plenty of room on the board to mount these, and that just gives me more overhead, not that it's really required. And I'll probably just go ahead and use 4 of these blue ones I got from DigiKey. Just, it'll look a little more consistent perhaps. He's got bags of resistors here as well. Some jumper wire. He supplied machine pin sockets, which are really nice, but I'm not going to replace the double wipe sockets I've already got on the board. There's no reason to. A doubled up heatsink. I've done this before. I didn't have a larger heatsink. I don't know how well you can see this in the plastic. The larger heatsinks I had like this were pools, and they were kind of beat up and wouldn't have looked nice. And when I saw what he'd done here, I went, I'm just going to go ahead and use what he provided. Why not? The 0.1 microfarad despiking caps, these are actually a good size. They're 0.1. I had found in my stock these really large ones, which I was a little unhappy with, just because of the absolute physical size. They're a little big, especially when you've got boards stacked in a back plane that are close together. He's also got, the old school ceramic capacitors here for the other values, and I didn't have all of these. So I went, it wasn't cheap, it wasn't super expensive to buy this, and yeah, I spent extra money with all the doubled up parts, but I just said, screw it, I want the right crystal. There's a few other things here. Why not? And so I just spent all the money and bought it all. So, with all that said, I think we need to move on to resistors. And I'll make some decisions here as I look. A lot of this I can set aside for now. We won't be installing it until later on. So get some room back here on the bench. He's provided some, I think those are probably 5-watt resistors for those 2 voltage droppers for the -5 and I believe -12-volt power supply rails. Those look much more like what the original photos are, and you know, it called for 2-watt. You can see going from 2-watt to 5. I think those are probably 5s. The difference in size, these look much more like what was originally, you know, on the board when it was manufactured. So I think I will end up going with those just because they look more period. We've got the assembly instructions here, and we start out with a bunch of 1K ohm, 1/2 watt resistors. He's got those bundled in over here. I also bought 1K ohm. I was nearly out of stock on the 1K ohms. I think that's them right there. No, that's 6.2. So resistors are really cheap, especially if you buy a larger-ish quantity, you know, of like 10 or 20. There's 1Ks there as well. What I bought and what he supplied are, you know, nearly identical. I think the ones he supplied are a little bit larger, so I'm going to go ahead and use those. I just want to, you know, they look a little bit more like what was on the original board. So let's dump all those 1Ks out of there. Got a nice little sea of 1K ohm resistors. And these are going to go in R1 to R8. This is R1 to R2. This was really hard to see. No, that isn't R1, that's R18, 24. Let's swap over to the other glasses. Let's see what we've got here. R1, 2, 3, R1 to R8, R1, 2, 3, 4, 5, 6, 7, 8. So that's this little bank right here. Let's see if I can determine a good size for bending those. We'll try. Right here. See how close that gets me. Oh, that's a little bit large. Of course, now I've got kinks in those leads. This is a case where there's a pretty large gap on the PCB for the resistor to fit into, and so I really do want the leads kind of bent, squarish, and looking nice is the first. Slot on there, perhaps a little closer. No, that looks a little bit big as well. Set that one aside. I've got plenty of these. Let's see if I can come up with a size I like. Looks like maybe 0.55. That'll drop down in clean. Nope, these are probably more like 0.5. Apparently I'm not real good at eyeballing at the moment. These are definitely, you know, the leads are very oxidized on these resistors. They're definitely They've been around for a while. Okay, 0.5 is a good spacing for those. That dropped in pretty well. Let me get the board kind of supported here. And we will need 7 more of those. One ohms, really the kind of the very typical pull-up resistor value around TTL logic. So as you can see here, those are lined up pretty well. I mean, the bodies do wander up and down a bit, but that's okay. But they're pretty consistent. They look pretty nice there. That generally went together pretty well. I've got one lead I'm kind of unhappy with that I'm going to bend down a little bit, just to be a bit more consistent. And of course now it's skewed slightly. Not that it matters. I think I'll just go ahead and tape them, and we'll see how many times I have to clean the tip here with the amount of oxidization on those leads. So there's the first 8 resistors. I will proceed with all of the additional resistors in the exact same way. I'm not going to record all that in real time. I'll capture it all, and we'll just play it back at 10 or 15x speed. Otherwise this would be a very long video. I am trying to kind of shorten the videos as I can. Anyhow, there's the first 8. So I've pretty much finished stuffing the resistors. You may have missed this in the high-speed video. It turned out that for these 470 ohm, there's 2 half watt and 2 quarter watt. I originally installed quarter watts here before I realized these are supposed to be the half watts, and I had to pull those off and move them over here and put the half watts in. The other thing is these 2 big power resistors down here. So they're R45 and R46, and they're down here. And you may have seen on the board I used part of a Q-tip as a spacer underneath these. So they're actually up off the printed circuit board. I did that so that you get maximum airflow around the resistors. All resistors dissipate some heat, no matter where they are. If there's current flowing, they're going to produce some heat. Power equals E times I. Based on the size of these, they are definitely designed to dissipate heat. These are 2 watt resistors minimum, and by getting them up off the board, like I said, you get better airflow. They stay cooler, but if they're actually touching the board, they transfer heat to the PCB. And if you've looked at an old PCB with power resistors, you'll see that the PCB material often is brown. It's been burnt over the years by the heat from the resistors. With the IC packages in, the height of these really is no more than about the top of a package, and there'll be a gap to the board on the other side. So this also becomes an issue where I've got CPU boards stacked in the cage, and I've got a board up next to this with heat. Now I think in this design, this is actually the first card in the cage, and all the cards go behind, so we'll have good airflow over these power devices, or these power resistors. The last thing to note, as you may have saw, I checked off every resistor I stuffed. R34 and R31 don't have resistors in them, and I do not see 34 or 31 called out here anyplace. So I'm not sure what I'm missing, whether they're just not stuffed, or whether I need to go back to the schematic and figure out the values. The reality is every resistor he supplied in the prepackaged parts kit I bought, I've consumed. We've used up all the resistors. He had exact counts. His counts were perfect. There was no extra resistors, but I've used all the resistors he supplied. So it really makes me think those 2 resistors probably aren't actually stuffed. So anyhow, with that, I will wrap up the resistor portion of the video here. In the next video, we'll tackle whatever comes next. So if you got this far, thank you for watching, and we'll talk soon.